The Smithsonian Invention Kits are a series of student experiences where students follow a narrative arc starting in 1800 when Volta invented the battery, taking a look at historical inventions that fundamentally changed our world and changed our society. And they're using advanced manufacturing technologies to reconstruct and rethink and reinvent those.
In the first Invention Kit, students created their own solenoids and used Fablevision's Maker Studio software to make electricity-powered pop-up cards. In the second Invention Kit, students reconstructed an AC generator where a permanent magnet is moving back and forth inside a coil of wire.
Today our kids did the linear motor, and really awesome experience. You know, kids are actually interacting with the curriculum, which is something that they don't normally get to do. It's really cool to see the kids be able to make their own invention and learn from it and actually see how it fully functions. We are producing a magnetic field just with the piece of wire. That means every wire right now in this room that has electricity going through it is producing a magnetic field. So why is it that this room, this compass, is not going haywire with wires everywhere with the electricity through it? Yeah.
So it's because the coils are so close together, the magnetic field gets amplified because there's so many close by.
I don't think I could have said it better myself. So the more wraps you have, the bigger the magnetic field you'll make. Isn't that pretty cool?
True that.
And with that, we can do unbelievable things.
This is definitely, I think it's alternating current. Because when you twist it, it comes out.
Yeah, and then if you look at it, it goes back down further.
Yeah, it like goes down. I mean, that's zero.
So the Smithsonian Invention Kits are implemented in my class through a collaborative group structure. Kids are working together in mixed ability groups. They all bring their own unique experience and prior knowledge with science, with history, and with engineering. One of the coolest experiences for me is because there's such a strong curricular progression, kids are actually anticipating what might be coming next by offering, hey, Mr. Martin, can we try this? Or what would happen if we did this? And so kids are already seeing the natural progressions and conceptual jumps.
Okay, so when it doesn't do anything, it's at 0, and then when you move it one way, it goes that, and then when you move it back, it moves back. But if you flip it, when you move it in, it goes negative, and when you move it out, it goes positive. So it's probably like the force is what's making the what? The magnetic.
So we need one that makes it measures like it more
Smaller.
more detailed, I guess. Like so it measures like so when something small happens, it measures it on a big distance. So it like makes it. I don't know how to say it. Like,
there's a word that starts with an S. A smaller
scale.
All right. There you go. There you go. Smaller scale. These Smithsonian Invention Kits have been transformational for me as the teacher in terms of planning. And I think they're really helping us to rethink what school could look like. School tends to be pretty siloed, right? Kids go to math, and then they go to social studies, and then they go to science. Yet they're not seeing the natural connections between those subjects. So within our engineering class, through the Smithsonian Invention Kits, kids are seeing the historical connections, the math connections, the science connections, and the engineering all wrapped in one in this this great narrative of how our country came to be the country that it is today.